first, this is a okay. Yeah, this is a figure. The math department. So we have 18 professors and 2 instructors and 2 postdocs. And the number of students as follows: first year students 77, and second year students 98. So yes, so we are from second year students now. We have the big audience now, and third and fourth year around 70 students. Actually, the current second year students started with around 75 students, but after the first year, many students from other majors transferred to math majors. So probably, I think the math major is kind of popular among the NUFYP university. So I hope also after this spring semester, also we're going to have more students transferred from other majors. And we have 22 master students, and we have 11 PhD students. Okay, now let me introduce our the faculty, and with some pictures and some musics. Okay, so here's the Dongming Wei, department chair. And Professor Abdul Wahab. And Alejandro, an expert in PDE. And Daniel, also expert in PDE. So I mean, oh, this new guy, but I haven't seen him just because he came here during the pandemic, unfortunately. And postdoc Adlet, he graduated from NU in 2015, and Jessica and the GBAC. Modak is an expert in mathematical biology. And probabilistic Karam. Mark. And that's me. Dance back. Modak. And our new instructor, Aigarim, she also graduated from NU, okay, 2018. And Bibinur, another postdoc. And Piotr, Durgukan, and Rustem, Ashane. Also, I haven't seen him because he came here 2021. Yelan and Roshan. Okay, so these are our faculty in the math department. Okay, so now, let me introduce now. Let me tell you how you can be the math major at another university. So you can be admitted as a math major. And even if you're admitted as a math major, that cannot guarantee you can be a math major for whole 4 years. I mean, you have to fulfill first year requirement to confirm your major. Okay. Now, what is the first year requirement for the confirmation of a math major? So you have to get the average GPA. I mean, GPA 3.0 on 2 courses, two first year math courses, Calculus 1 and Calculus 2. Okay, so if you fail to meet this requirement by the end of summer semester, so even if you admitted as a math major, if you fail to meet this requirement by the end of summer semester of the first year, then you'll be, unfortunately, we have to kick you out. So you'll be undeclared, or you have to change your major. Okay, so but the requirement is very simple. Okay, you have to get average GPA 3.0 on only 2 courses, Calculus 1 and Calculus 2. Then, well, let's suppose you kicked out. Okay. But then, is it possible to come back to math major? Yes, it's possible, but it'll be harder. Okay, which means you have to. So let's suppose you didn't meet the first requirement, so you became undeclared, or you transferred to other major. But you want to come back to the math major during the second year, then you have to meet another more strict requirement, not 3.0 on Calculus 1 and 2. So you have to meet more strict, harder requirement. So so if you apply for the transfer during the 4th semester of the second year, for example, but before the final exam period of the 4th semester, then, well, in this case, it's the same as before. The requirement is GPA 3.0 on Calculus 1 and 2. But if you apply for the transfer after final exam of the 4th semester, the second year, and before the final exam of the spring semester, which means that if you apply for transfer during the spring semester of the second year, then you have to pass at least 2 courses from these 5 second-year math courses with minimum C, and you have to get GPA 3.1, not 3.0, on 3.1 on all math courses taken. Okay, so if you try to transfer to the math major during the second year, then you have to take more math courses, and also your GPA must be 3.1, which is higher than first stage requirement. Also, your total number of credit must be less than 90. And if you apply for transfer after the final exam of the spring semester and before the start of the 4th semester of the third year, then now you have to pass at least 4 math courses of. I'm sorry. You have to pass 4 math courses from these 5 second-year courses with minimum C, and also, you have to have GPA 3.1 all math courses taken, and total number of credit must be listed to 120. Okay, and you usually do not accept the transfer of the third-year students. Okay, so you have to, if you want, you have to transfer to the math during the second year. Okay, then now the curriculum. First, yes, this is common curriculum. That's common NU core curriculum. But this is common curriculum. But in case of a research method course, okay. I'm sorry. In case of this research method course, so there are a few research method courses that are new, but math students must take a Math 350. This is the research method in mathematics. Also, in core curriculum, all NU students must take 1 math course, but in math major, we will count Math 160 on Calculus 1 for this course. And natural science elective. So in original, the annual core curriculum, so NU students must take at least 6 credits, but we in math department we put 2 more credits. So you must take 8. You must earn 8 credits in natural science, and also CS programming courses. So you have to also earn 8 credits, okay, in CS courses. Okay, in the second year, so we have 5 math courses. So you're supposed to take all these 5 courses with minimum grade C, because these 5 courses are prerequisite for other math courses in third year. So you have to pass all these 5 courses during the second year with minimum C, because the C is the passing grade for the prerequisite for all other math courses, not C minus. Okay, so in some other majors, C minus is passing grade for prerequisite, but in math, you have to earn at least a C grade. And in the third year, so you will take these these 4 mandatory courses, which are supposed to be very hard, not very hard. I mean, well, students says these are hard courses, but anyway, so you have to pass these mandatory courses. Here, to graduate, you have to earn at least a C- in these math courses, in these mandatory courses. In 4th year, you will have some chance to do undergraduate research through this capstone project. So you all math students will have to take these 2 capstone projects. Okay. So these are just the mandatory courses. Also, you have to take some elective courses. So you have to take at least 7 elective courses. Among them, you have to take at least 4 courses from 400 level. Okay, it's very advanced level. Also, you have to earn at least a C- grades from these math elective courses. If you earn, for example, D or D+, then they will not be counted as math electives. Okay, so you have to earn at least a C-. And also, you'll take 18 credits from technical electives. Technical elective means, so in math, for math students, technical elective means some courses from biology, chemistry, economics, physics, and some engineering courses or the mining courses. Then that means you have to take some courses outside math major. Okay. Also, yeah, you have to take at least 1 course from 300 level or 400 level from these non-math courses. So in addition, you have to take more general electives. So as you know, I'm not sure if you know or not, so the total number of credits for graduation is 240. So you have to earn at least 240 credits for graduations. Okay, so if you're a math major, then this is the recommended course plan. This is not the required plan. So this is recommended course plan. So usually students do not follow this course plan, but this is a recommended course. So if you're a math major, then in the 1st year, you will take just calculus 1 and some natural science or some core curriculum course and so on. So in 1st year, so you just take calculus 1 and calculus 2 only. Okay, if you're very diligent, or if you think you're very good at math, then in spring semester you can take some other 2nd year course as well. But usually students take just calculus 1 and 2. Just focus on these 2 courses to confirm their math major. Okay, because you have to earn at least a 3.0 on these 2 courses. The 2nd year, yeah, now in the 2nd year, so you take usually 3 courses per semester. And now in the 3rd year and the 4th year, now you'll take now at least around 4 math courses. Okay, so you'll be very busy during this 3rd year. Okay, you take around 4 math courses, and these the 300 level or 400 level courses are hard, so you'll be very busy. Yeah, this is the year 4. Okay, so that's the curriculum. Okay, now, so now let me show so where the math students go after graduation. So this is some statistics for recent years. As you see, well, I mean, this 2020, this statistic is kind of the stranger thing, because yeah, well, we had pandemic from the spring 2020. So so the amount of these students, I mean, this number is kind of the odd number. So usually students can get employed or go there. Usually they go to the graduate school. And so these are some the examples of where they go. So here, yes, so usually they go to the many of them go to some abroad, for example, UIUC or and so on. And So yeah, this guy is successful, has some successful story. So I actually introduced this guy in the faculty of the math. Now he is the postdoc in math department. So as I know, yeah, he got the Bolashek scholarship for the master in the University of Manchester, and then he went to Oxford for the PhD. Now he's the postdoc in our department. And then to the back, he graduated 2016. Now I'm not sure. This information kind of outdated. So 2 years ago, I heard that he was still the student, PhD student at the Stanford University, but I'm not sure right now what he is doing. And okay, now here are some students who went to the industry. Okay, and also lastly, the Sarah Red. I remember these students. I taught her some probability course. Now, yes, she went to some company in Poland, but still I'm not sure. I'm not sure what she's doing right now because I got this information just a couple of years ago. So anyway, so yeah, so many students, many math students went to the graduate school or the industry. So in case of industry, so many students went to the industry in the financial industry or the insurance company or and so on. So because actually we offer a few courses in financial math or the probability course, which are very useful in this kind of industry. So these courses are very popular in our department. So if you become the best major, then even if you cannot be, even if you do not want to be the professional mathematician, you still have some chances to learn mathematical skills in financial or the economic industry and so on. So yeah, so yes, that's the short introduction. That's it.
All right, well, thank you very much, Professor Lee. I was going to save questions till the end, but if anybody has any now that they'd like to put in the chat or just ask, maybe Professor Lee would be willing to answer those really quickly. If not, that's okay. I think that we're going to have Professor Fan present next. Oh, sorry, there is a question here from Gohar. She's wondering if it's possible to double major. I'm not sure what double major are you thinking of, Gohar? Oh, sorry, go ahead, Professor Lee.
Yes, I heard that we have in our university, so we have this system, this policy on the double major. If you fulfill both requirements in both majors, for example, if you want to double major in math and physics, and that means you have to fulfill all requirements in both departments. So virtually is we have this system, but virtually is it's not easy because because both department have their own requirements, but you have limited times of 4 years. So well, we have that we have this double major program, but it's hard. Okay, it's hard to do the double major within 4 years. If you go to one more year, if you go to the 5th year, then maybe it's possible. But I'm not sure. So but so to answer the question, yes, we have this program, double major program.
Dear Eric,
yes.
Sorry for interrupting.
No, you're fine.
We have Alminia. We have Alminia from ASA, from Academic and Student Affairs Office. She can answer this question, I guess.
Okay,
Thank you, but I think Professor Lee explained the process quite detailed. So if you're planning to do a double major, you need to first take all the courses for both majors, complete them successfully, and after that there is the form in my register that you can apply where you can get all the confirmations, and after that the information will appear in the system and you will have the second major.
Okay, thank you very much.
Well, one more thing. So another issue in doing double major is, so sometimes the course when you want to take some course in math, some course in computer science, for example, then well, it quite often happens that time conflicts. So if you want to take this mandatory course in math department and this mandatory course from computer science, but sometimes class times conflict each other, so sometimes it's not possible to take both courses in the one semester. So some students have the complaints about this, but we cannot control. Okay, so each department has their own time schedule, course offering schedule. So, but we do not consider those students who are doing double major. So unfortunately, sometimes, yeah, it's very hard. It's hard to do double major because of this kind of the reason.
All right. Well, I will go ahead and hand things over now to Professor Fan so that she can begin her presentation. Thank you very much, Professor Lee.
Okay, just give me a minute. There's some problem here. Okay. All right, there we go. So I would like to introduce the BSc program in chemistry department. And I was once the director of undergraduate program, but now Dr. Timur Atabev would be. So, but anyway, it does not stop me from introducing chemistry department to you. So we are the department that have 9 professors, like assistant professors, associate professor, and 1 full professor, which is our chair, Dr. Parnov. And so we have had a BSc program for this year. This is like 10 years, and it's a 4-year degree and 240 ECTs. So I would like to start with the curriculum. So if you have learned a chemistry course, so you should be quite comfortable to take general chemistry 1 and 2 for the first year. So those are 2 core courses and in the first year. And you also required to take 1 Gen Chem lab. So originally it was 2, so now we reduced the material into 1. So hopefully when the pandemic is over, we will be able to have hands-on laboratory. So and then you are required to take calculus 1 and calculus 2. And keep in mind that chemistry really requires much in your mathematical skills. So if you wanted to apply what you have learned in mathematics, so chemistry is a good course to have practice. And second year, the core would be organic chemistry. So in the past, students all complain like how difficult organic chemistry is. So right now we have quite a few instructors and along with our faculties. And so we have a quite strong instruction team. in organic chemistry. So we will be able to help you to go through this course and with a passing grades at least. And for the students who want to learn more, and we always have extra resources and to push you to a much higher level. So that's also durable. And then second year, we do also descriptive inorganic. And from third year and beyond, it'll be like a chemistry core course. So usually we have about average 15 students in chemistry major. So once you get to this point, you get a well taken care because one professor teach 15 students. You will definitely get enough attention, enough help, enough guidance. So even though, so that's why we want more students to be interested in chemistry program. So we have capacity for 20, and usually students on their third year and beyond, they do research with our faculty. So they participate in research and even either as a form of course independent study or as a hired student researcher. So they can get paid of $100 a month to do research with faculty, which is really a good opportunity to train you all the skills to do scientific research. And the fourth year is mainly some electives and so far and so on. So from last year, from this year, we start to have direct research. It is a course that requires students participating in research anyways, so you need to participate in research. Again, we have enough faculty and who can mentor you in these researches and help you to go through these courses and prepare for your future. So our students usually have 3 directions to go after they graduate from a chemistry program. And one of these group, like it takes up 1/3 of our graduates, and they go to pursue more advanced study. So they either go to abroad to pursue PhD program, PhD degree, or a master degree in US or European country. So in this case, we have already sent quite a few. In the little bit later, I will introduce quite a bit of students. They obtained a full scholarship in US and Canada or European country. Not even Bala Shock, they got a full scholarship from that foreign country to support them pursue PhD or master degree, and some students pursue master degrees or PhD. We're going to have PhD degree. We'll start this fall. We will start have PhD in chemistry department. So and also some students go to like a medical school and also a school of engineering, and that's 1/3. And the other 1/3 of students, they're interesting. Quite surprisingly, they're interested in to be a scientific teacher in Turkish high school, and or some students they go to Nazarbayev Intellectual School. So this is not a bad job, and the students really enjoyed their teaching in these high schools. So especially when they finish the chemistry degree, it seems like they have very good understanding in the science course in a high school. So they've done a great job. And I met some of my students who become the teachers at NIS school. So the other 1/3, they get employed in the local companies in food industry, oil industry, which is also quite good, and also the chemicals salesman and so far and so on. So they also quite enjoy their job, and some of them come back to NU to get some measurement done, and because they are trying to overcome some challenges in their work in their job in oil company or in food industry. So very interesting. Some students even do jobs and environmental related jobs. So here we go. And we have a faculty team, our chair, Dr. Parnov, myself, Dr. Balani, and Dr. Bakasov, Dr. Kalamon, and Dr. Otto Bergenov, and Dr. Pashkov, Dr. Abatov, and Dr. Adilov. So these two are postdoctors, Dr. Mekanova and David, and all these three, Dr. Moon, they are postdoctors, and we have 4 instructors. And so they all have, most of them have PhD degree. And so this is our faculty. So their research, Dr. Parnov is doing like a biomaterial related research, and his group is trying to developing some nanoparticles that can be used in antimicrobial effect. So such kind of research. And Dr. Balani's research is concerning the solar, like a battery, fossil, like a fuel cell, and also environmental related, also like a material science orientated research. And myself, and I am a physical chemist. I doing research in fundamental theory, and also nanomaterial. So I synthesize some carbon-based nanomaterial that has anti-cancer, antimicrobial properties. And Dr. Bakasov is, you find out, yeah, everybody is doing material science. So it's interesting. He's doing like Raman spectroscopy, and Dr. Kalamon and organic synthesize some homogeneous catalyst. And Dr. Darhan, his research is on protein, structure of protein, and the functioning and mechanism related study. And Dr. Pashkov also organic synthesis, and he synthesized some organic dye that has fluorescence, photoluminescence at different wavelengths. Dr. Atabayev is again a material scientist, and he is synthesized some nanomaterial that can be used in the measurement, like NMR measurement, and sometimes would apply to a different area, so imaging technologies. So Dr. Adilov is the organic chemist, and his research focus is on like crystallographic. So he is trying to make a supramolecular crystal and study the structure. So in a way, he designed and synthesized a very special structured crystal and to fulfill special function. And David, our postdoctor, his research is on electrochemical to synthesize some organic compound that has electrochemical properties. And so Dr. Anara, another postdoctor, and her focus is synthesize of functional carbon-based nanoprobes. And again, and she has some overlap in her research with Dr. Atabayev. So Dr. Alia Tolanova, she is the instructor, just came like last year. So her research is again about electrochemical engineering. And she is mainly, if you take a chemistry major, so she will be likely be your teacher to to teach you general chemistry. Okay, so this is our alumni have been distributed, and where are they working? They working in like a different kind of area, and chemical company, and see universities, and also to work in the local company. So these are the graduate school our graduate students went. So so far, I think there are like 6 students from our chemistry major went to Marquette University. They got a full scholarship, and 2 or 3 at Brock University in Canada, and we have 1 in the University of Liverpool. So like they kind of went to the universities all over the world, and they perform very well. And Marquette University is where I got my PhD. So my mentor told me that all the students that from NU, and they are the best among their graduate students. So I feel really proud of our students graduate from here. So, and you guys, if you would like to choose chemistry major, so there are like a very wide potential for your choice in the future. So you can do all these kind of branches, and then you can be an educator, and you can work in pharmaceutical, and also environmental related workforce, and forensic, and material science, and biochemistry. So there are so many different potential jobs that you can pursue with a chemistry major BSc degree. So you can also, if you are, some students think, oh, chemistry is too difficult, I want to take a biology. But if that's your choice, you can always take chemistry as a minor. So if you decide this, and you can talk with our staff to find out a specific requirement. Okay, so I think that's all I wanted to present to you guys. If you have any question.
All right, thank you very much, Professor Fan. If anybody has any questions, as she said, feel free to ask them or just type them in the chat, and we'll make sure that we answer them. Okay. Well,
No question.
maybe we'll get some more as things go on. But for now, I suppose, like I said, thank you very much, Professor Fan, and we'll have Professor Malafarina go ahead and present.
Yes, let me share. Can I share this? Is this working?
Yeah, I can see
can
it.
You, Can you see it? Yes.
Yes.
Okay, so hello. Yes, I'd like to start with a few minutes on something slightly different, because I have the impression that very often students, when you're very young, you're a bit confused about where you are getting into a topic or a subject to study. And lots of people think, okay, will I get a job? Which is something that you should consider. But if that's your only goal and you choose something that you don't like, then you'll end up competing with other people that are as good as you, and they also enjoy what they're doing. So make sure that you pick something that you enjoy doing. And there are differences between all of these sciences. And I would like to spend a couple of minutes to try to make you understand what are the peculiarities of being a physicist. Because physicists are problem solvers in some sense, in the sense that they don't use the available tools to actually build something or solve something, but they do create the tools that are adapted to a specific problem. So what you will get after 4 years when you finish a physics degree is a completely different way of looking at the world. And you will look at the world through a mathematical lens, an experimental lens in which you see patterns. You see the common properties that then maybe appear in different kinds of systems. They could be, I don't know, fluid dynamics if in oil pipelines, but it could be traffic in the city center. And then you will see the common features of that and the common equations that can help you understand what's going on and how to solve it. That's why typically physicists, they tend to find job a little bit everywhere in society, because you have, from all backgrounds, you have lots of people that have a training that is very specific to one thing. And that may be true also for physicists, of course, but also if you learned to be a physicist in the more broad sense, you will have a training that allows you to see the general patterns of something, regardless of that what that thing is. And so that is why typically physicists, they can find jobs in the financial sector or in biology labs, for example, or in politics other times. So I guess in the list here, you see a bunch of physicists, and I hope you know that all of these guys were physicists, but maybe not all of you know that these people are also physicists or have the degree in physics. And you can see there's a couple of famous politicians, Angela Merkel, who recently quit her position as Chancellor of Germany. There's a couple of people that were influential, are influential in the industry, very famous Elon Musk or Robert Goddard, that not many people know, but the Goddard Space Center at NASA is named after him, and it was one of the pioneers in rocket science. And you can find, if you look at Wall Street, for example, you will find lots of physicists, like, for example, the guys that did benefit from the crash of 2008. And there's even books on financial physics, on how to apply the laws of physics to financial markets. And then, just for curiosity, a couple of musicians, because, physicists, they tend to do a bit of everything. So I will just try to explain a little bit what I mean by this with background from what I know, which is basically gravity, yes? So why do we care about learning about gravity? The whole point is to give a society, to give a group of people, to give humanity, depends on to what kind of identity you belong, to give an evolutionary advantage or an advantage over something else, somebody else. So I would study gravity because I want to understand why the moon orbits the Earth. But at the same time, if we are in the 16th century, 17th century, the fact that I know the laws that govern the motion of projectiles gives my country an advantage over the opponent country that is shooting their cannons at random, while we can calculate exactly where our cannonballs are going to land. So there is practical advantages from the application. Yes, I'm not going to build a cannon, but the laws of physics and the laws of gravity are going to be useful for the guys that want to build the cannons for their armies. And I guess these days, these are topics that are maybe even too important nowadays. Advantages, they're not, of course, only in the military sense. There can be technological advantages. Me, for example, I work on strong gravity. I work on the theory of relativity and black holes and so on. And when Einstein developed the theory of relativity, he was doing it because he wanted to understand what gravity is. He wasn't thinking what I could do with it. But today, I guess, all of you have a smartphone and all of you use Google Maps or some similar app to geolocate yourself and to find a path to wherever you want to go. Well, that GPS, global positioning system, would not work without the general theory of relativity. Einstein was not thinking about that, but a deeper understanding, that ability to look forward at something that is beyond what we need right here and right now, brought technological repercussions 50, 100 years later. So if you want to have an impact on technological society today, be an engineer. If you want to study the fundamentals of how the universe works, of how the laws of physics work, and how patterns tend to bring together different aspects of different phenomena, that may have technological applications later on, maybe in 50, maybe in 100 years. It is important to have people that do both, because if we focus only on what we can get here and now, we are basically removing all the potential for applications in the future. And in fact, there was a recent study by the IMF, International Monetary Fund, so it has nothing to do with physics, it has to do with banks and money, that showed that fundamental sciences are more important than applied sciences for the future economic growth of a country. Why is that? Because if I invest all the resources of my country, let's think about Kazakhstan, in engineers, those engineers have to catch up with lots of engineers for other countries that have been doing that for a longer time and that have the know-how already. It's important to do that, of course, and so we have to invest in that. But if we want to have a competitive edge later on, you need to invest in those people that will come up with the science and the technology of the next 50 years, not of the things that we're using today. And that you do it investing in physics and in fundamental sciences, not necessarily in engineering. So it doesn't mean that you have to put all your money in things that will have applications in 100 years. It means that every country that has put a portion of their money into research in science that has potential applications in 50 or 100 years, those are the countries that have been leading economically later on. This is what the United States have done in the 30s and in the 40s. All the German scientists left Germany during the Nazi regime. They moved to the United States. They were free to do whatever they wanted. And then all the benefits of that science, we have them today. And this is the reason why one of the reasons why United States is one of the leading economies in the world. You want to compete with them. Do not think about what is the science that we're doing now. Think about what is the science that we're going to do in 20 years. You want to know what that is? Then you have to study physics. Of course, we get lots of cool knowledge out of it. For example, the discovery of gravitational waves, that is how gravity propagates, that nobody knew they existed until 7 years ago. So that led to a Nobel Prize in physics, to the people that discovered that. And that was an experiment that is a mind-blowing effort of human ingenuity that took more than 40 years from the conception until the first discovery. And physicists, they did it for the knowledge. They did it to actually learn something. But the technological repercussions of that, they're coming, and they will be coming for the next decades. All the technology that was needed to develop this kind of experiment eventually ends up in our lives. And these are the guys that got the Nobel Prize for the discovery of gravitational waves. So I mentioned about the global positioning system. Einstein was not thinking about that. Einstein was thinking about gravity, but this is what we got as a byproduct of that. So when you choose a major, when you choose what you want to do, choose something that you like. And keep in mind, if you're choosing physics, you're choosing something that most likely will not have an immediate impact right now or tomorrow. It's something that is going to be a little more long-term, and you're going to be more in the dark because you're not going to do something that people give you the instruction manual and you apply it and you build it. You're going to explore things that nobody has done before. And so very often you will hit the wall and you will have to go back and do it again and so on. So it's a lot of hard work with very little reward, because the success stories, of course, are much smaller than the cases in which you try for a long time and nothing comes out of it. But it's not true that nothing comes out of it, because what comes out of it is an enlarged and a better knowledge about the universe we live in. And when you can see this universe from a little bit of afar, you get a better understanding of the dynamics that are at play around you. I use physics and I use the math that I learned for my job now when I have to understand how people behave, when I have to understand why governments make some decisions, when I have to understand why the university administration is doing something. And when you look at all of these things through the lens of dynamical systems that tend to go towards a certain state for whatever reason, then it becomes more impersonal and easier. Okay, so having said that about physics, let's take a couple of minutes to talk about physics department. This is a couple of pictures of us. We have a wide selection of courses, from the fundamental ones to lots of elective courses. We have research opportunities, of course. We have internships. We sent students to conferences and internships abroad in the past during the summer, and we produce a lot of research, some of that also with our own undergraduate students. If you're aiming at doing research, at being a scientist, then the opportunities would be in the form of some courses that you can take during the summer to learn some things and then to do research with your advisor. But, and then towards the end, all of that effort is going to go into what we call an honor thesis, which is basically a thesis in which you describe the work you've done. On the other hand, not everybody wants to actually do research. You want to get a degree in order to get this different mindset to look at problems that is valuable outside, that is valuable, for example, in the city planning or in the finance sector. So you don't want to do research in physics. Then you don't have to do a thesis. You don't have to go through this honor tracks, and you can just take the courses, learn the stuff, and get your degree. So there are these two parallel ways. That is, one is more aimed at somebody that wants to actually focus on science and have experience in doing research in science, and the one that is aimed at people that only want to get the degree, learn what you can learn about physics and math and all the tools that are necessary to actually break a problem into its constituting parts, and then come up with solutions, and then go out and offer your services to whoever wants to hire you. And here, while I'm talking, you can have a look at some of us and what we work on. We see there's a bunch of people that work on experimental things. Anton Desniatkov is not our chair, that works on photonics and lattices. And we have a few people that works on this kind of devices, metamaterials and laser-based and photonics materials. On the other hand, we have also a group of people that are more theoretical. Sergey, for example, is computational. He's at the border between physics and chemistry because he's doing something that is kind of quantum chemistry. So he's doing theoretical descriptions of molecules, essentially. And this is more theoretical and computational work. And along that line, we have Professor Abdi Kamalov that is doing computational astrophysics, and myself and Professor Good that are working on theoretical aspects in gravity, more related to astrophysics. So there is a bit of experimental, there is a little bit of theoretical, and you can find a bit of everything within the department. So here are a bit of the research areas. And if you want to have research experience, then at some point, I would suggest around the second year, you approach your professor, you say you would like to learn something. There are some elective courses that you can take that give you credit for what you've been learning. Typically, they are in the summer. These are 299 and 399 courses. And then there is the opportunity to become a research assistant and get a little salary if you are actually producing some results. And sometimes some students also end up producing papers with their advisors. As I said, there are opportunities for internships and works in labs. We have facilities on site here or at the university. There's a few advanced labs for laser and photonics, but also we have a couple of institutes that we collaborate with in Kazakhstan that are the Energetic Cosmic Laboratory. If you're interested in astrophysics, they are looking for gamma ray bursts that are huge explosions in the sky. And they are very difficult to track because they last for a very short amount of time. So you need a telescope that is able to move very quickly towards the signal and actually take the spectrum of that object. And this telescope was built near Almaty by the Energetic Cosmos Laboratory. So there are opportunities to doing research with them as well. And then recently there was the INURA accelerator that was inaugurated that is for more material sciences. That is basically a linear accelerator in which you shoot particles on top of targets of other particles and essentially see what happens to characterize the properties of materials. These are research institutes based here in Kazakhstan that we are related, we have connections with. But at the same time, we've sent students for internships very often at Berkeley National Laboratories. We sent some students to Cambridge in England, South Korea, or United States. As you can see here, some of the example, Danat, who went to Princeton, or Sabina, who went to Cambridge, and MIT. So what happens? You get the degree, and what do you do afterwards? If you want to continue your studies, we have a pretty good track record of sending students to very good universities in North America or in Europe over the last 8 years or 9 years. I was here since 2014. So if you want to continue your studies, you should go with the honors track. You should produce a thesis and then apply. And almost 100% of our students, I think in the last 5 years, there was one case of one student that was aiming too high and applied to very few universities, only top Ivy League universities, and did not get admitted. That was one case. But typically, on average, students apply to 5 or 6 places, and all of them, they get at least one offer. And these places, they usually some of the best places. Or the other option is you can go and look for a job. And physicists, they get jobs in government institutes where for different government bodies, or in private companies, or in the financial sector, and so on. I don't know if I have the time to talk about that. A couple of minutes. How much time do I have?
You still have a couple of minutes if you'd like to just talk about it a little bit. That's fine.
No, then I go with a couple of minutes. So here is a few of the students that went on to do their masters and PhD. Batir, who was my student, we produced one paper, and then he was admitted with scholarship at MIT. And then you can see and got them to lots of good universities around the world. So I'll take these last couple of minutes to talk a little bit more about the actual program. So I will share the slides so you can read all of these things later on. So you can find all this data online. So there is no need to go through the actual numbers and so on. As you know, there is a core curriculum. So at the beginning, you will have to study some core courses, of which the core physics course is Physics 161, which is Physics 1, and then some math courses and so on. But the real physics starts from the second year. And the second year, you will have some more intensive physics courses for which you will have to have built your math muscles with Calculus 1, Calculus 2, and linear algebra in order to be able to actually understand what's going on in the more advanced mathematics of the physics courses, because physics requires math. Don't think you can become a physicist even in a lab without having a very deep and strong knowledge in mathematics. And then later on, so these are the core courses and the typical ones that you can find throughout curricula around the world: classical mechanics, quantum mechanics, electrodynamics, and so on. And as you can see, there's 4 math courses that are core for physics, because, as I said, you cannot get anywhere in physics without a good, solid background in math. So be ready for that. And then there's a bunch of elective courses that you can take at the 200, 300, 400 level, in which you can study things that are more interesting to you, especially when you go to the 300 and 400 level. You see there is 399 Physics Research Project. This is an actual course that gives credits in which you may be doing research with your supervisor. This is what I was talking about before. While the corresponding one, 299, in my view, is used as an approach to your research. It's a course in which you learn the basics for what will be the research that you want to do. So in the second year, you learn the tools. In the third year, you start doing research. In the fourth year, you write your thesis. So I think we are getting towards the end. Here is a sample of the schedule. I think I will just let you have a look at it for a little bit. As you can see, this is third year, no, as the first year. First year, you can see not much physics in the first year, fall and spring, physics 161, 162, quite a bit of math, calculus 1, calculus 2, linear algebra, all very important, and a bunch of other things. From the second year, you start with serious stuff, classical mechanics, modern physics, and then a little more math, differential equations, and so on. And then you get to thermodynamics, and then you go to electrodynamics, quantum mechanics, and so on for the third and the fourth year, where you actually do your real physics and you pursue what was your original interest, whatever you wanted to study or do research with. And I think with this, I will stop. I had a bunch of other stuff to talk about, but I think I can stop it here. And thank you for listening.
All right, well, thank you very much, Professor Malafarina. Does anyone have any questions for anyone who's presented today? Because I think Professor Lee and Professor Fan are also here as well. Feel free to type them in the chat, or you can just, go ahead and shout them out. Anybody? Well, I guess no one has any questions. I assume that's a good sign that you've covered all of the bases for them.
They all fall asleep.
Yeah, either that.
There's also that possibility.
Yeah, that is a possibility, I suppose. Okay, well, if no one has any questions, then I want to thank the three of you for coming today and volunteering your time and your information. I'll make sure to post this recording for all the students to have access to, and any students that weren't able to come. And hopefully we'll see some future physicists, some future chemists, and some future mathematicians as a result of this.
So thank you for doing this. Should I also share the slides with you? Should I send you the
I still have the slides, if they're the same ones that you had sent last time. Yeah, so I have them all.
I think so. Okay.
Yeah, and again, I want to just like I said, thank you all for coming again today. And I'll make sure if anybody wants these slides, students, you can let me know and I can send them to you. That's fine with me.
Okay, thank you very much.
All right, thanks everyone. I suppose with that, yeah, we'll go ahead and wrap things up. I'm going to stop.
Have a good evening, everybody.